In this video, I will show how to find the magnitude and the direction angle of a vector given in algebraic form. So we can quickly sketch this vector just to understand what is that we're looking for. So negative I means it's going -1 in the horizontal direction, and negative 5j means it's going down 5 in vertical direction. So 1, 2, 3, 4, 5. So this is the vector that we trying to find the magnitude of and the directional angle. So first, let's recall the formula for the magnitude of a vector. When the vector is given in algebraic form, we can always find the magnitude by simply applying the Pythagorean theorem. That is, the magnitude is always the square root of a squared plus b squared. So in our case, magnitude of v will be equal to square root of -1 squared plus -5 squared. So it's just square root of 26. Now, to find the angle, what angle are we looking for here? We're looking for this angle alpha. And what do we know about this angle alpha? We know that tangent alpha is equal to the vertical component over horizontal component. So in our case, the tangent alpha will be equal to -5 over -1, which is 5. So we're looking for angle alpha in third quadrant, whose tangent is equal to 5. That sounds like we're trying to solve this equation. Tangent alpha equals 5 for alpha between pi and 3 pi over 2. So this simple trigonometric equation can be solved by finding the tangent inverse of 5 and adding pi k to it, where k is some integer. So there are infinitely many solutions. However, only one of these solutions is in the interval between pi and 3 pi over 2. Well, which one? So if I just pick tangent inverse of 5, tangent inverse of 5 is in the domain of the inverse tangent function, so it must be between -pi over 2 and pi over 2 exclusively. So that means what? That means if I'm looking for an angle between pi and 3 pi over 2 that satisfies the condition that tangent of the angle is equal to 5, I simply have to choose k equals to 1. So if I choose k equals to 1, that will add pi to tangent inverse of 5, and it will put it in the third quadrant, and that will be the angle that I'm looking for. So if I set k equals to 1, the answer will be tangent inverse of 5 plus pi, and we can use calculator here to find the tangent inverse of 5, which is 78.7 degrees. As you can tell, it's in the first quadrant, and that's why we have to add 180 degrees. So the final answer is 258.7 degrees, and this angle is in the third quadrant. So the final answer is the magnitude of vector v is square root of 26, and the direction angle is 258.7 degrees.